Think about it. What if something exists, simply because it always has? No creator, no origin, just an infinite loop of existence. In Dark, we see this play out with the stranger giving Jonas a time machine that he later builds himself. But here's the problem. Who actually invented it first? That's the bootstrap paradox, a time loop with no beginning, no end, and no logical explanation. And trust me, once you start thinking about it, you'll never see time the same way again. What is the bootstrap paradox? Imagine you find an old book filled with groundbreaking scientific discoveries. You study it, memorize every formula, and years later, you publish the same book. But here's the twist. Where did the original knowledge come from? Who actually wrote it first? This mind-bending scenario is the essence of the bootstrap paradox, a time loop where information or objects seem to exist without ever having been created. The bootstrap paradox is one of the strangest puzzles in time travel theories. Unlike the grandfather paradox, which questions whether you could erase your own existence by changing the past, this paradox doesn't break time. It bends it in a way that challenges our entire understanding of cause and effect. It's a loop with no clear beginning, no point of origin, and no logical creator. Everything exists simply because it always has. But does that mean it ever truly existed at all? Think about it. What if a scientist from the future goes back in time and teaches Einstein about relativity? Einstein then grows up, develops the theory, and the future scientist learns it from Einstein's published work before traveling back again. Who originally came up with the idea? If the information has no starting point, does that mean it's been borrowed from nowhere? This paradox is not just a thought experiment, it has been a major inspiration in science fiction, philosophy, and theoretical physics. The concept forces us to question everything we know about time, existence, and reality itself. If something can exist without being created, does that mean the past, present, and future are already written? Or is time more flexible than we ever imagined? The bootstrap paradox isn't just about time travel, it's a riddle that teases the very limits of human comprehension. And if we ever unlock the secrets of time manipulation, we might find that reality is much stranger than fiction. Bootstrap in fictions. Science fiction has been playing with the bootstrap paradox for decades, crafting mind-bending stories that leave us questioning everything. Let's start with a simple yet mind-twisting example: a musician who learns to play a song from an old recording. Years later, he records the same song, and that recording becomes the very one he learned from. So, who originally composed it? If you can't answer that, congratulations, you've just encountered a bootstrap paradox. One of the most famous examples comes from Doctor Who. The Doctor explains the paradox using Beethoven. Imagine you go back in time to meet Beethoven but find out he never existed. Shocked, you publish all of his compositions from memory, becoming Beethoven yourself. But if you only knew his music because of the future, and the future only knew it because of you, where did the music actually come from? Then there's the Terminator, where Skynet sends a killer robot back in time to eliminate John Connor before he can lead the human resistance. But here's the twist. The remnants of the destroyed Terminator become the foundation for Skynet's creation. That means Skynet was never invented. It just always existed because of a time loop. Christopher Nolan's Tenet plays with this paradox on a deeper level. Characters manipulate time by passing information and objects back and forth, making it impossible to determine an original source. A character gives instructions for a mission that will save the world, but those instructions only exist because they were received from the future. No origin, no beginning, just an infinite loop of cause and effect. And let's not forget the Harry Potter series, where Harry receives the invisibility cloak from Dumbledore, which was passed down through generations. But what if someone had traveled through time and placed the cloak in the past for Harry to receive? That would create an object with no true origin, forever cycling through time. These stories don't just entertain us, they make us question how time really works. If something exists only because it always has, does it truly exist? Or are we all just characters trapped in a story that has already been written? Theoretical implications. Time travel isn't just a wild fantasy, it's something physicists seriously consider. And the bootstrap paradox is one of its strangest implications. If an object, an idea, or even a person loops through time without an origin, does that mean it was never truly created? Can information exist without a source? This paradox breaks the very thing we rely on, cause and effect. In our everyday world, everything follows a logical sequence. You wake up, you get dressed, you go about your day, one event causes the next. But the bootstrap paradox throws all of that out the window. Imagine a scientist who builds a time machine after reading blueprints found in a mysterious box. Years later, he travels back in time and leaves the same blueprints in that very box for his younger self to find. Who originally designed the machine? The answer? No one. The information just exists, trapped in a self-sustaining time loop. This idea isn't just a sci-fi gimmick. Quantum physics suggests that time might not be as linear as we think. Some theories propose that the past, present, and future all exist simultaneously, and what we perceive as time moving forward is just our limited way of experiencing reality. If that's true, then the bootstrap paradox isn't just possible. It might be how reality actually works. The paradox also raises an unsettling question. Can we ever truly create something original? If ideas, inventions, or knowledge can theoretically be passed through time without a real origin, does that mean the future has already happened? If so, is free will just an illusion, and are we simply following a script that has already been written? Some scientists believe that the paradox suggests a predetermined universe, where everything, including every thought, every action, and every discovery, was always meant to happen. Others argue that reality would prevent these loops, maybe through quantum randomness or some undiscovered principle of time. But until we truly understand time, the bootstrap paradox remains one of the greatest mysteries of the universe. Related paradoxes. The bootstrap paradox isn't the only mind-melting mystery in time travel. It's just one piece of a much larger puzzle that challenges everything we know about cause and effect. If you think an object existing without an origin is weird, wait until you hear about these other paradoxes that make time itself seem like a cosmic prank. First up, the grandfather paradox, a classic dilemma in time travel. Imagine you go back in time and accidentally prevent your grandfather from meeting your grandmother. That means one thing: you were never born. But if you were never born, then who went back in time to stop them from meeting? Just like that, you've erased your own existence, creating a contradiction that time seemingly can't resolve. Some scientists suggest that time might self-correct to prevent such paradoxes, but if it doesn't, reality itself could break. Then there's the predestination paradox, which is like the bootstrap paradox but applies to events instead of objects. Picture this: you have a vision of a tragic accident, so you rush to stop it. In doing so, your actions accidentally cause the very accident you were trying to prevent. The event was always going to happen. Your attempt to change it only ensured it did. This paradox suggests that some things are just inevitable, no matter what we do. The Fermi paradox isn't a time paradox, but it's worth mentioning because it deals with another big mystery. If the universe is so vast, where is everyone? Could time loops or paradoxes be preventing civilizations from developing? Could an advanced species have discovered time travel and accidentally wiped itself from existence? It's a terrifying thought, but one that scientists seriously consider. Lastly, let's talk about the twin paradox. Not quite a contradiction, but a bizarre outcome of Einstein's theory of relativity. If one twin travels near the speed of light and returns to Earth, they'll have aged much less than the twin who stayed behind. This means time isn't fixed, it's flexible, changing depending on speed and gravity. If time itself is this strange, maybe paradoxes aren't impossible at all. Maybe they're just how time really works. Reflection. The bootstrap paradox is more than just a weird thought experiment. It's a challenge to everything we believe about time, reality, and even existence itself. If something can exist without ever being created, what does that say about the universe? Are we living in a reality where time isn't a straight line but an infinite loop, constantly feeding itself with knowledge, objects, and events that never had an origin? This paradox forces us to ask a deeper question. Is time truly linear, or are we just perceiving it that way? Imagine if past, present, and future all exist at once, and we're simply moving through them like a needle on a record. What if history isn't written before or after? What if it just is? Some physicists argue that time might be a block, where everything has already happened, and we're just experiencing it in sequence. If that's true, then maybe bootstrap paradoxes aren't violations of time. Maybe they're just proof that time works differently than we think. But here's the real kicker. If a time loop can create something from nothing, does that mean free will is just an illusion? If knowledge, objects, or even events exist because they always have, does that mean our choices are already predetermined, or do we have the power to break the cycle? The bootstrap paradox doesn't just raise questions about time, it makes us rethink the very nature of choice, destiny, and existence. And what if this paradox isn't just fiction? Imagine a future where time travel is possible, and people start sending knowledge back through time. Would we ever be able to tell what ideas were truly original and which ones were borrowed from a future that hasn't even happened yet? If history can be rewritten, would we ever know what the real timeline was? The mystery of time travel remains unsolved, but one thing is certain: the bootstrap paradox is a puzzle that refuses to be neatly explained. Maybe the answers are hidden in the future. Maybe they've already been discovered, just waiting for someone to bring them back in time. Or maybe, just maybe, they were never created in the first place. Time travel, paradoxes, and infinite loops. The universe is stranger than we can imagine. The bootstrap paradox is just one of many mysteries that challenge everything we know about time. But what if time isn't broken? Just misunderstood? If you love exploring mind-bending concepts like this, subscribe to InnoVision Tech for more deep dives into futuristic science, technology, and the unknown. Hit the like button, drop a comment, and let's keep pushing the boundaries of imagination. Imagine waking up one day, looking at the night sky and realizing something is off. The stars seem distorted, planets aren't where they should be, and scientists are sending urgent warnings. What's happening? A black hole is entering our solar system. And no, this isn't a sci-fi movie. This is what could happen if one of the universe's most terrifying forces drifted too close. Would Earth survive? Could we escape? Or would we get stretched into cosmic spaghetti? Buckle up, because today we're diving into the terrifying reality of a black hole invading our solar system. Let's get started. What is a black hole? Alright, let's start with the basics. What exactly is a black hole? Imagine something so powerful that it can swallow stars, bend time, and make light itself disappear. That's a black hole for you. It's a region in space where gravity is so insanely strong that nothing can escape, not even light. Sounds like something out of a sci-fi movie, right? But these monsters are very real. Now, how do black holes even form? Well, when a massive star reaches the end of its life, it explodes in a supernova, and the remaining core collapses under its own weight. If it's heavy enough, boom, it turns into a black hole. It's like nature's ultimate vacuum cleaner, but way, way more terrifying. And guess what? There are different types of black holes. You've got stellar mass black holes, which are a few times the mass of our sun. Then there are the supermassive black holes, millions or even billions of times bigger, sitting at the centers of galaxies like cosmic kings. And then there are the mysterious primordial black holes, which might have formed right after the Big Bang. Scientists are still debating whether these exist. But wait, can we actually see black holes? Not exactly. Since they trap light, we detect them based on their effects. When a black hole feeds on nearby matter, it forms a glowing disk of superheated gas called an accretion disk, which shines brightly in X-rays. That's how we've spotted them lurking in deep space. Oh, and here's a crazy fact. The closest known black hole to Earth is about 1,500 light-years away. That's far, but in cosmic terms, not that far. So what if one started moving toward us? Let's find out. The likelihood of a black hole encounter. Okay, so could a black hole actually wander into our solar system? Before you panic, breathe! The good news is the chances of this happening are incredibly low. But let's entertain the possibility anyway because, well, space is wild, and anything's possible. First, how do black holes even move through space? Some black holes are formed from dying stars, but others, so-called rogue black holes, get flung across the galaxy due to powerful gravitational interactions. These loners drift silently through the cosmos like cosmic assassins. If one of them came our way, we might not even see it until it was too late. Now, statistically speaking, how worried should we be? The Milky Way alone contains over 100 million black holes, but space is vast, like, really vast. A black hole just randomly entering our solar system is like throwing a dart in the middle of the ocean and hoping it hits a single fish. Not impossible, but ridiculously unlikely. But what if? Even if a black hole just passed by the outer edge of our solar system, it could still cause chaos. Its gravity might send comets from the Oort cloud hurtling toward the inner planets, including Earth. Not exactly the kind of meteor shower you'd want to witness. And here's something even crazier. Some scientists believe there might already be a black hole in our solar system. Some theorists suggest that the mysterious Planet 9 could actually be a primordial black hole, lurking somewhere in the outer regions. If true, that would change everything we know about our cosmic neighborhood. So, while the chances are slim, the possibility isn't zero. And if a black hole did enter our solar system, well, buckle up because things would get terrifying real fast. Gravitational effects on the solar system. Alright, let's say a black hole has somehow made its way into our solar system. What happens next? Short answer, chaos. Long answer, well, let's break it down. First, the planets would go completely out of whack. See, black holes have an enormous gravitational pull. If one were to drift close enough, it wouldn't just gobble up planets. It would distort orbits, send planets spiraling into space, or even crash them into each other. Mercury, gone. Venus might get yanked toward the sun. Earth, let's just say things wouldn't end well, and it gets worse. Even if the black hole didn't directly swallow us, its sheer gravitational force could stretch and tear apart planets through something called spaghettification. Yes, that's a real scientific term. Imagine everything on Earth being pulled in different directions like strands of spaghetti. Yikes. Now let's talk about the sun. You might think a black hole would suck it in instantly, right? Not necessarily. If the black hole were small, the sun might actually stay intact, but get dragged off course. That alone would mess up the entire solar system, plunging planets into darkness or causing extreme temperature shifts. Speaking of temperature, here's a terrifying thought. If a black hole passed through the Oort cloud, the distant shell of icy comets surrounding our solar system, it could send a tsunami of comets hurling toward Earth, a cosmic shooting gallery, except we'd be the target, and before you think, we'd see it coming, right? Maybe not. A small black hole, especially a primordial one, might not emit much radiation, making it nearly invisible until it's too close. And by the time we noticed, well, let's just hope NASA has an emergency plan. Impact on Earth. Alright, let's get personal. How would this affect Earth? Spoiler alert, it wouldn't be pretty. Even if a black hole didn't swallow us whole, just passing nearby could turn our planet into an unrecognizable wasteland. First up, our orbit would be completely messed up. If a black hole's gravity pulled Earth even slightly closer to the sun, we'd experience scorching heat waves, burning forests, and dried up oceans. If we got pushed farther away, say hello to an eternal ice age where the entire planet would freeze over. Either way, we're doomed. And that's not even the worst part. The tidal forces from a black hole are so extreme that they could cause massive earthquakes, volcanic eruptions, and tsunamis. Cities would crumble, landscapes would change overnight, and survival would be nearly impossible. And let's talk about the atmosphere. If the black hole came too close, it might strip away our protective shield, leaving us vulnerable to deadly cosmic radiation. That means the sun's rays would cook us alive, and solar storms would wipe out all electronics. Forget the internet. Human civilization itself could collapse in days. And if the black hole came even closer, well, we'd get stretched into spaghetti. Spaghettification, yes, that horrifying term again, would turn Earth into cosmic noodles, breaking apart our planet atom by atom. Not exactly the kind of pasta you'd want on your plate. So yeah, if a black hole entered our solar system, Earth wouldn't stand much of a chance. The real question is, would we see it coming? Signs of an approaching black hole. So, can we even notice a black hole creeping into our solar system? The short answer? Maybe. The long answer? It depends on how it behaves. First off, black holes don't glow like stars. Since they trap light, they're invisible unless they're actively feeding on matter. So if a rogue black hole were wandering toward us without consuming anything, spotting it would be incredibly difficult. But here's the catch. Black holes have a gravitational pull strong enough to warp space itself. If one got close, we'd start noticing strange anomalies in planetary orbits. Astronomers would see Neptune or Uranus slightly shifting in ways that defy physics. That would be a huge red flag. And then there's the radiation factor. If a black hole started feeding on dust, gas, or even small asteroids, it would emit high-energy X-rays. Our telescopes would pick up these signals, alerting scientists that something massive and unseen was approaching. One of the scariest signs? A sudden increase in comet activity. If a black hole disturbed the distant Oort cloud, it could send a wave of icy comets and space debris hurtling toward us. Imagine the night sky lighting up with countless fireballs, at first beautiful, then terrifying. And let's not forget time itself would start acting weird. The closer a black hole gets, the more it warps time and space. If we saw light bending in bizarre ways, or if clocks in different locations ticked at different speeds, we'd know something unnatural was nearby. So, yes, we'd probably have some warning signs, but the real question is, could we do anything to stop it? Theoretical possibilities. Now here's where things get even crazier. What if there's already a black hole in our solar system? Sounds like sci-fi, right? But some scientists think it's possible. Let's talk about Planet 9. For years, astronomers have suspected there's an unknown massive object lurking beyond Neptune. Some theories suggest it could actually be a primordial black hole, a tiny but incredibly dense remnant from the early universe. If true, that means we've had a black hole hiding in our solar system this entire time. But what if we tried to fight back? If a black hole was heading our way, could we somehow deflect it? Well, not really. A black hole's gravity is so strong that nukes, rockets, or anything humans can build wouldn't even scratch it. Our best bet would be figuring out how to escape Earth entirely, which, let's be real, isn't exactly an easy option. Some crazy ideas suggest we could manipulate a black hole using lasers or massive gravitational waves. But, yeah, we're nowhere near that level of technology. If a black hole was coming, our only real move would be watching helplessly as it reshaped our entire solar system. And here's the wildest part. Black holes might hold the key to the biggest mystery of all, the nature of time itself. Some theories suggest that inside a black hole, time stops or even loops endlessly. Could falling into one mean experiencing eternity in a split second? We still don't know. So while a black hole invading our solar system is unlikely, it's not impossible. And if it ever does happen, well, let's just say, we'd be making history in the worst way possible. So, what do you think? Could we survive a black hole invasion, or would it be game over for our solar system? The universe is full of mysteries, and this is just one of them. If you enjoyed this mind-blowing journey, don't forget to like, share, and subscribe to InnoVision Tech for more futuristic and space-related content. Until next time, stay curious and keep exploring the unknown. Imagine waking up 100 years in the future, cities floating in the sky, AI running the world, and humanity exploring distant galaxies. Sounds like science fiction, right? But what if time travel wasn't just a fantasy? What if the secrets to bending time were hidden in physics, waiting to be unlocked? From Einstein's theories to real-world experiments, scientists have uncovered mind-blowing clues that suggest time travel might actually be possible. But how close are we? Is there a way to break the rules of time? Buckle up, because today we're diving deep into the future of time travel. Understanding time travel. Ever wished you could hit rewind on life? Or maybe fast forward to the future? Well, guess what? Time travel might not just be science fiction. It's a real possibility, at least in theory. The laws of physics suggest that time isn't as straightforward as we experience it. It bends, stretches, and even slows down under the right conditions. Mind-blowing, right? It all starts with Einstein's theory of relativity. Unlike the ticking clock on your wall, time itself is flexible. It changes depending on how fast you're moving or how strong gravity is around you. This means that time isn't an absolute universal constant. If you were speeding through space at near the speed of light, time for you would slow down compared to someone on Earth. So, in a way, time travel forward is already happening, just on a very tiny scale. But what about traveling back in time? That's where things get tricky. In theory, certain solutions in Einstein's equations, like wormholes or cosmic strings, suggest it could be possible. However, there's a major roadblock: paradoxes. Imagine going back in time and stopping your grandparents from meeting. Would you even exist? This is the infamous grandfather paradox that makes backward time travel incredibly complicated. Scientists continue to explore theories like wormholes, black holes, and quantum mechanics to crack the mystery of time travel. But for now, while the math hints at the possibility, technology is nowhere near making it a reality. The question isn't just can we travel through time, it's should we? Forward time travel. Here's something wild. Time travel to the future is already happening. Not in a sci-fi movie way, but in real, measurable physics. We're all time travelers, moving 1 second per second. But did you know that with enough speed you could skip years, even centuries, into the future? Thanks to Einstein's special relativity, we know that time slows down for objects moving at extreme speeds. This phenomenon, called time dilation, has been proven with high-speed jets and atomic clocks. Put simply, the faster you move, the slower time ticks for you compared to someone standing still. So, if you were traveling in a spaceship near the speed of light, years could pass for people on Earth, while you'd only experience a few days or weeks. And it doesn't stop there. Gravity also affects time. The stronger the gravitational field, the slower time moves. Astronaut Scott Kelly spent 340 days in space, and when he returned, he was slightly younger than his twin brother, who stayed on Earth. Why? Because Earth's gravity slows time down for him compared to Scott, who was in orbit. This means forward time travel isn't just a theory, it's proven science. The catch? To truly leap into the distant future, we'd need to travel at near light speeds, something far beyond our current technology. But who knows, maybe one day space travelers will return home to find centuries have passed, while they've only aged a few years. So, while backward time travel is full of paradoxes, forward time travel, it's not a matter of if, it's a matter of when. Backward time travel. Alright, let's get to the real mind-bending stuff, traveling back in time. Imagine stepping into a machine, dialing in a date, and suddenly finding yourself in ancient Egypt, or warning the Titanic before it sinks. Sounds incredible, right? But here's the catch. Backward time travel is way more complicated than moving forward. Physics doesn't outright forbid traveling to the past, but it throws a bunch of challenges our way. The biggest issue? Paradoxes. Ever heard of the grandfather paradox? If you went back and stopped your grandparents from meeting, you'd never be born. But then who traveled back in time in the first place? It's a loop that breaks reality. Some scientists argue that time might fix itself in weird ways, preventing changes that would create contradictions. Others suggest multiple timelines, meaning if you change the past, you'd just create a new alternate universe instead of rewriting your own. So how could we actually go back in time? One idea involves closed time-like curves, predicted in Einstein's equations. These would allow you to loop back in time, but so far we don't know if they could exist in the real world. Another theory, cosmic strings, massive, ultra-dense objects stretching across the universe that might warp spacetime enough to allow for time loops. But there's no evidence these strings exist. Then there's the biggest question of all. Even if we figure out how to travel backward in time, should we? If history could be rewritten, would we even recognize our present? The past might be set in stone for a reason, or maybe we just haven't found the right key yet. Wormholes. If you want to time travel like in the movies, you need something better than a DeLorean. Enter wormholes, hypothetical tunnels through space and time. If they exist, they could connect two distant points in the universe, allowing you to step into one end and instantly pop out in the past or future. Sounds too good to be true? Well, it might be. A wormhole, also called an Einstein-Rosen bridge, is basically a shortcut through space-time. Picture space as a sheet of paper. If you fold it and poke a hole through, you create a direct path between 2 points. In theory, if you move one end at near light speed or place it near a supermassive gravitational force, time inside the wormhole could pass differently than outside. This could create a natural time machine, but here's the problem. Keeping a wormhole open is nearly impossible. The moment anything tries to pass through, it collapses faster than you can say, flux capacitor. To stabilize one, you'd need something exotic, literally. Scientists believe a form of negative energy, which we haven't discovered yet, could hold it open. Without that, a wormhole would be more of a cosmic death trap than a time portal. And let's not forget the paradoxes. If wormholes allowed backward time travel, we'd run into the same problems as before. Could you travel back and erase your own existence? Would the universe even allow that? Some scientists think time travel paradoxes might fix themselves through quantum mechanics, meaning any action you take in the past just creates a new timeline rather than affecting your own. So, are wormholes the answer? Maybe. The math works, but the technology is pure science fiction, for now. The real question is, if we ever did find a way to open one, would we be brave enough to step through? Time travel future prospects. So, we've talked about theories, paradoxes, and even wormholes. But here's the real question. How close are we to making time travel a reality? Well, let's just say, don't pack your time machine suitcase just yet. The truth is, while the math behind time travel works, our technology is nowhere near capable of making it happen. First, let's talk about speed. We know that traveling at near light speed slows down time for the traveler. But here's the problem. We don't have anything that can move that fast. Our fastest spacecraft, the Parker Solar Probe, moves at 430,000 miles per hour, but even that is just 0.06% the speed of light. To time travel significantly into the future, we'd need to reach at least 90% of light speed, and right now that's impossible. Then there's the issue of energy. Wormholes? They need negative energy to stay open, and we haven't figured out how to create or harness that yet. Even if we did, stabilizing a wormhole would require insane amounts of energy, far beyond anything we can generate. Think about it. We're still struggling to make nuclear fusion practical, and that's child's play compared to what time travel would demand. And let's not forget gravity. Black holes might hold the key to time manipulation, but good luck getting close to one without being spaghettified. Scientists theorize that extreme gravitational fields slow down time, but harnessing that effect in a controlled way, that's not happening anytime soon. So, is time travel impossible? Not necessarily. Science is always evolving. A few centuries ago, the idea of flying across the world in hours was unthinkable. Now we take it for granted. If we crack the mysteries of quantum mechanics, advanced propulsion, or even exotic matter, who knows what doors might open? One thing's for sure, the future of time travel is uncertain. But hey, maybe some future traveler is watching this right now, laughing at how clueless we were. If that's the case, drop us a hint, will ya? So, is time travel just a dream, or are we closer than we think? While science has given us glimpses of what's possible, the technology is still far behind, but who knows? Maybe in the future someone watching this video will be the one to crack the mystery of time travel. If you enjoyed this deep dive, don't forget to like, share, and subscribe to InnoVision Tech for more mind-blowing tech and science content. Until next time, stay curious, stay futuristic, and keep exploring the unknown.